Today I start the second part of solution, solubility of the gases. First I discuss the solubility of solid in liquid. Solubility means that maximum amount of the solute which can be dissolved in a specific amount of the solvent at a given temperature. Now if you see, first of all, solubility of a solid in a liquid. Solute plus solvent, it convert into solution. The two processes are continue at the same time, that is the dissolution and crystallization. What do you mean by dissolution? When the solute dissolve, the maximum solute dissolve and the concentration of the solution increases. At the same time, the solute molecule collide with each other and the process crystallization starts. So the rate of dissolution is equal to the rate of crystallization. That is known as a saturated solution. Means a solution at this stage is said to be saturated solution. Or you say that the solution in which no more solute dissolve at a given temperature. If more solute can be dissolved at a same temperature, then solution is called unsaturated solution. So finally we define what do you mean by solubility, the maximum amount of the solute or solid in gram which can be dissolved in 100 gram of liquid or solvent to form a saturated solution at a given temperature. The second thing that is very important, what are the factors affecting the solubility of a solid in a liquid? The two factors are very important. One is the nature of the solute and solvent. Second is the temperature. Third is pressure. But pressure have no effect in the solubility of a solid in liquid. So first we discuss nature of the solute and solvent. You see, one very good quotation is there, like dissolve like. Means a ionic compound generally dissolve in polar solvent, whereas the ionic compound are insoluble in organic solvent. Similarly, covalent molecule are soluble in organic solvent. What the reason is there? In a solid, the solid molecules are close together by the two force, electrostatic force of attraction as well as the lattice energy. But when this solid added to the solvent, hydration enthalpy, the amount of energy released. So if the hydration energy is greater than lattice energy, the substance is said to be soluble. So a substance dissolves if the hydration enthalpy is greater than lattice enthalpy. Temperature, you know that the chemical reaction are two types, in which the heat is required to dissolve a solute in solvent, that is called endothermic reaction. And if heat is evolved when a solute is added to the solvent, it is called exothermic reaction. So in case of endothermic reaction, if we increase the temperature, the solubility increases. But in case of exothermic reaction, the solubility decreases with increase in temperature. These are the example you see: sodium nitrate, potassium nitrate, NaCl, KCl. When you dissolve, it's an endothermic reaction. But at the same time, sodium carbonate, lithium carbonate, they are dissolved, and this is the exothermic reaction. So in first case, solubility increases with the increase of temperature. Here the solubility decreases if we increase the temperature. But I just mentioned no change in the change like that, that is the polymorphic form. I mentioned one example here. Here no effect of temperature. The second part of today's discussion is solubility of a gas in a liquid, and that is also called Henry law. Now almost all gases are soluble in water to different extent. One of the example, you know that the life of a aquatic organism, it totally depend upon the solubility of a gas in water. So these are the very important part. Why it is important? You know that the solubility of a gas explain many phenomena. Here also the factors affecting the solubility, the nature of the gas, temperature, but beside that one important factor is the pressure, and that pressure effect of the pressure is explained by Henry law. Nature of the gas, you know that why generally gases are soluble, it depends upon the two factors. One is chemical reaction and second one is called chemical similarity. Temperature, solubility of a gas decreases with increase in temperature. What the reason? You see here, the dissolution of a gas in a liquid is an exothermic process. You see from this graph, the solubility of oxygen is maximum, whereas the solubility of nitrogen is less in comparison to the oxygen. So, as when the gas dissolves in liquid, it is exothermic reaction. So, effect of temperature, that if we increase the temperature, the solubility decreases. You can also understand that aquatic animals are more comfortable in cold water in comparison to the hot waters. Now come to the effect of pressure, and that is also called Henry law. Generally what happens? On increasing the temperature of a gas, the solubility increases. What the reason behind this? You see from this diagram, if we increase the pressure here, the molecules are come close together and they increase their solubility, and that is explained by Henry. So what is the Henry law? That is the effect of pressure on the solubility of a gas in liquid. According to the Henry, the statement is the mass of a gas dissolved in a given volume of a liquid at constant temperature is directly proportional to the pressure of the gas pressure in equilibrium. So M is directly proportional to P, where M is mass of the gas solute, P is the pressure of the gas. Here we use proportionality constant K. So M equal to Kp. But according to the Daltons, if a mixture of the gases are simultaneously in equilibrium with the liquid at a particular temperature, then mole fraction is directly proportional to the partial pressure. So if you just reform the equation number 2, Pa equal to 1 upon K dash Xa, we use here the term Kh. So final mathematical expression of the Henry law comes Pa equal to Kh into Xa, where Pa is the partial pressure of the gas, Kh Henry constant, and Xa is the mole fraction. Now from the graph also you can easily understand, if a graph plotted mole fraction versus pressure, we get a straight line graph and the slope of the graph is Henry constant. So partial pressure of a gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. It is the final statement of Henry law. Now what is the importance of Henry constant? Henry constant is a function of the nature of the gas. Greater the value of Kh, lower is the solubility of the gas. The value of Kh increases with increase of temperature. If you remember these 3 points are directly the region-based question from these chapters. Now what are the limitations of Henry law? Henry law is totally applicable for the ideal gas situation where the pressure should be low and temperature should be high. This is the condition for the ideal gas. The gas should not undergo compound formation. You see from this example, ammonia interact with water, it forms the ammonium hydroxide, and ammonium hydroxide again break into ammonium ion and OH minus ion. So these, if you remember these two limitations, then that is very easy to explain how, where and when Henry law is applicable. Now come to the application. That is very important part of this topic. As you know that the cold drinks, everyone prefer the cold drinks if we kept in fridge. If it is outside the fridge, no importance. Why? What the reason behind this? Now, cold drink is prepared under the high pressure, and in fridge, as the temperature low, the pressure increases and the solubility of the gas increases, which make it tasty. Such situation is according to the Henry law, and that is very, very important for the production of carbonated beverages. Second, in the driving, sea driving, the deep sea driving, you know that the people take the oxygen and nitrogen. What happen when you go inside, the oxygen in the water decreases, at the same time the nitrogen interfere, and which causes the bend, that is also called the decompression or sickness. One of the most application of the Henry law, that is the function of the lungs. And the last one, for the climber, the people living at high pressure, there is also a problem come anoxia. This topic is not only theoretically important, it is numerically also important. I mention here some questions. The NCERT example 1.4, in text 1.6 to 1.7, exercise 1.13 and PYQ, that is the CBSE previous year questions. So if you solve all this numerical, this topic is important, theory as well as numerical purposes. Thank you.